So a couple of years ago, we had one of these comets go by the sun, and we set up to watch it because we didn't know what we were going to learn. We had seen one before, and it had disappeared before we could figure out what we could learn. And a comet Lovejoy in December of 2011 came around the sun, and we did an event like we did today where we set up the data so that people could look for it. And it was actually quite a nice comet. We were really pleased. We saw this really nice tail, and then when we pointed back to normal solar pointing, we saw an even nicer tail. So now when we see these, we realize that the reason the tail looks so interesting is because as the comet goes by, it sees the sun's magnetic field, and the material from the comet jumps up and down in the sun's magnetic field. So some of it goes one way and some of it goes another way. And that's telling us about the sun's magnetic field. And that's a place in the corona where we have a hard time measuring the sun's magnetic field. So if now all of a sudden these comets can tell us what's going on, just the direction at first, and then maybe we could figure out how strong it is. That's pieces of information we can use to better understand how the sun makes a magnetic field. And then as we get more into it, why is it bright was a pretty good question, because we didn't quite understand why cold material coming off would be bright. It should be dark because of our way things work. And it wasn't, it was bright. And so that meant that there was something else happening as well. And that's when we found out that oxygen was a really good probe of what was going on in the corona. And then that allows us to know that anything we see glowing is probably oxygen, and we can study how that oxygen gets hot. And then the third thing that we would like to look for, and this is what I really hoped Ison would do for us. Ison was going to put material into a place very close to where the Earth orbits around the sun. So it would come out along the same plane that the Earth goes around, and we might actually be able to measure this material when it gets out to the Earth, or to when it goes to the two stereo spacecraft, which are around behind the sun, a color. We thought we did see Comet Lovejoy reflecting light, and in that case, it would have been kind of a yellowish green like anything else that's kind of white. So sorry, we don't really get a color.
And right now it's looking like we may not be able to see it after this perihelion. A lot of people out in the social media world are commenting on that, whether or not we're ever going to see it again. And people are hoping it's not. One of the questions we just got in says, is it dead, or is it just maybe just that SDO can't see it?
I would have to say that if SDO sees nothing, since we see almost every oxide, so we see anything that's a rock, that's an iron, that's any kind of carbon molecule, they all have some oxygen in them, and water has oxygen in it as well. And if it has oxygen, as it went around the sun and came out, we would have seen that oxygen. So it would have to be something that doesn't have very much oxygen in it. And I find that would be a strange kind of material to make it around without releasing oxygen like that. So, it's already surprised us once today. Maybe it will come out and we'll see it on the other side. We should know several hours from now, when the tail would start to rebuild, whether the comet will be visible again.
And let me throw in another question about survival. I'm going to throw this one to Alex Young. He is one of the solar scientists here with us today and that means Dean is leaving, so he seems to be waving goodbye. Thank you, Dean, for joining us. He is going to go back to looking at the Solar Dynamic Observatory pictures and seeing what they're getting in on their data. Alex Young is also a solar scientist here at NASA Goddard.